Goes out to all the people who simply requested examples of doing chain rule. I've got a function inside of a square, and that function on the inside is the sum of two other functions, and one of those is a square root of another function. This is classic chain rule in that you may be used to taking the derivative of x squared. Bring the 2 down, leave the x, notch this down by 1. But when the something that is squared or square rooted or has the sign taken of it or something fancy, if it's not just x, you're going to have to use chain rule. Here's what I mean. If this was x squared, the derivative of this would have been 2 times x all to the power of 1, right? But it's not x. So instead, we have to keep what's on the inside of the brackets the same. This is me copying out the function, plus 6x. See, there's that copied out. The 2 came down, keep that the same, notch the exponent down by 1, times, and then we have to take the derivative of what was on the inside of the brackets. That's this. Now, how do you take the derivative of this? Well, a square root function is also written as whatever is under the square root to the power of a half. How do you take the derivative of that? You bring the half down, you keep what's inside the same, just like we did over here, right? Notch this down by 1, so 1/2 minus 1 becomes negative a half. And because what was on the inside of that bracket wasn't just x, we also have to multiply that by its own by the derivative of what that is. And that is 6x. I'm bringing the 2 down, minus 4. Oh, that's just the derivative of this function. I still have to take the derivative of this, because remember, the only reason we're in these large square brackets is because we're taking the derivative of what was on the inside of the square brackets here. So we have our plus 6. Oh, man, wasn't that crazy? Let me reiterate what happened there. We took the 2, we brought it down, and notched it down by 1. But because this wasn't just x, we had to multiply that by the derivative of what was on the inside. On the inside, we had an even more complex function where we had to bring the half down, notch it down by 1, and take the derivative of what was on the inside of that and multiply it in. This is why it's called the chain rule, because when you have a function inside a function, inside a function, inside a function, you end up taking the derivative of the very outside, then the derivative of what was on the inside of that, and the derivative of what was on the inside of that. And it just keeps going and going and going until you work your way to the inside of the whole function itself. Cool? Cool. So that wasn't part of it. You could clean this up. I don't know if I feel like bothering with that. Actually, this 2, I'm going to multiply it through. That cancels with the half there, and then just simply makes that 12. So that made that a little bit easier. So where I'm at right now is this square root 3x squared minus 4x plus 1. You can stop the video right now if you want. I'm just cleaning this up. Times, we've got 6x minus 4 times 3x squared minus 4x plus 1. That's actually square rooted, and it's 1 over that. That's what the negative half means. Plus 12. That was nothing. Ignore that too. I don't picture this simplifying much more than it already has. I could probably factor this out, but I don't really feel like bothering. I've shown you what the chain rule is, and I want you to practice some on your own anyways. Cool? All right, enjoy life.